can you solve this geometry challenge? Here's the question. Given these three circles having the same center, and these are called concentric circles, also given these tangent segments 20 units, 21 units, and this x units. And of course, the question is, what is the length of this tangent segment x? Now pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question is 29 units. So the length of this tangent segment x is 29 units. Now the question is, of course, how do we get the value of x, or these 29 units? And here's the solution. The concept that we need to answer this question is what we call the power of a point, or what we call the chord-chord power theorem. So this chord-chord power theorem is used when two chords intersect inside the circle. And when we have that condition, we can multiply both parts of the chords together, then set them equal. On our given figure right over here, we can say that wy, this part of the chord, times yn equals iy times yd. And now, to apply this theorem, what we're going to do is to look at our figure in different perspective. Because this tangent segment, we can put this right over here, can be in this position, but what we need is in this position, right about in this position. Because using the symmetry of this figure, if we put this tangent segment right about in this position that connects to segment x, this is also 20 units. Also take note, if we extend this green tangent segment, this part on the upper part is also 21 units by symmetry. And also, we can put this tangent segment in this position. But of course, what we need here is we need to connect these three tangent segments as much as possible, like this. Now, from this intersection, let's extend this chord. And now the question is, what is the length of this? So we know for sure, from this point up to the end, this is x. And from this point to this point is 20. In short, this black segment is simply equal to x minus 20. Now, we don't need this small circle and also this medium circle. What we need is the big circle, because we can now use what we call the chord-chord power theorem. So using the chord-chord power theorem in this figure, we can say that x plus 20 multiplied by x minus 20 equals 21 squared. Now simplify, this is just x squared minus 20 squared equals 21 squared. Now add 20 squared on both sides, we have x squared equals 21 squared plus 20 squared. And now at this point, we can also use what we call the concept of Pythagorean triples, because we have a Pythagorean triple 20, 21, 29. In short, 21 squared plus 20 squared simply equal to 29 squared. And if we want the value of x, this is simply equal to 29 units. And that is the value of x. Therefore, given this configuration, the value of this segment x simply equal to 29 units. And now, let's have a simple challenge. Take note that if we square this tangent segment 20, add to this tangent segment 21, so 20 squared plus 21 squared simply equal to 29 squared. Now, can you find the correct configuration on this figure so that we can use the property of a right triangle? Because take note, these 3 points creates a right triangle. Now, I will wait your answer on the comment section down below. So see you on our next video. And as always, we are done.